exciting because the fundamental question is, are we dealing with a natural icy rock, a rock covered with ice, a natural object, or are we dealing with a technological spacecraft?
The alarm does not come as a sound. It comes as a graph that refuses to behave. Deep in space, interstellar comet 3Y Atlas suddenly lights up in X-rays. Not a flicker, not noise, a sustained, powerful signal. Scientists watching the incoming stream know instantly this is wrong. Comets are cold, dark, passive. They do not glow like this. Two space telescopes, separated by distance and mission, register the same thing at the same time. The confirmation hits like a shockwave. This is not a glitch. This is not background radiation. This is real. A red, high-energy halo stretches outward from the comet, expanding fast, hundreds of thousands of miles into empty space, far beyond where sunlight should have any effect, far beyond the comet's visible coma. What's glowing is invisible to the eye, but violently alive at the atomic level. This is not reflected light. This is matter being ripped apart. Charged particles from the sun, solar wind, are slamming into material that did not form here. Atoms are stripped of electrons. Energy detonates outward as X-rays. The interaction is brutal, precise, and relentless. Scientists realize they are watching our star collide with alien chemistry for the first time in human history, and the scale makes no sense. The X-ray footprint is enormous, too large, too diffuse, too intense. Models fail immediately. Known comet physics can't explain how the glow spreads this far, this fast. Something is feeding the reaction. Something is amplifying it. The comet is not inert. It is responding. The halo grows unevenly, warped, stretched as if shaped by forces still invisible in the data. The glow doesn't sit neatly around the nucleus. It leans. It bends. It behaves like a structure under stress. Scientists scramble to update simulations in real time. Every attempt to shrink the interaction zone fails. Every attempt to limit the energy output breaks another assumption. The more they calculate, the worse it gets. 3I Atlas is not just passing through the solar system, it is engaging with it. And the reaction is stronger than anything predicted. The question shifts from what is happening to something far more dangerous. Why is this interstellar object reacting so violently to our sun? As analysts dig deeper into the signal, a second realization begins to surface, one that suggests this flare was not an isolated event, but the opening move in something far larger. Because this was only the first telescope to see it, and another one was already watching. The confirmation hits like a second impact. There is no room left for error. XRISM has already stared for 17 straight hours, its instruments locked onto the same impossible signal, watching the glow refuse to fade. Now, XMM Newton steps in, observing for nearly a full day, and the result is worse than feared. The X-ray emission is not shrinking. It is spreading, stretching outward to nearly 250,000 miles from the comet's nucleus, far beyond anything that should be possible. This is not a flare. This is a structure, and it should not exist. Scientists freeze as the overlay appears on their screens. Two different spacecrafts, two independent detections, the same massive halo. The numbers match, the angles match, the distortion matches. Any hope that this was a calibration glitch or a rare noise spike dies instantly. This glow is real. It is stable enough to persist for hours, yet violent enough to radiate high-energy X-rays into empty space. Something is feeding it continuously, and no one yet knows what. The size alone is deeply unsettling. Ordinary comets show X-ray emission only in tight regions where solar wind brushes their outer gases. But this glow is hundreds of times larger than expected. At this scale, The interaction zone dwarfs the visible comet itself. What appears as a faint smudge in optical telescopes is, in X-rays, a sprawling battlefield. The comet is not a point object, it is surrounded by an invisible envelope vast enough to swallow planets. Then the gas signatures appear, and the tension spikes again. Hydrogen, nitrogen, lightweight elements that should be nearly undetectable at this distance suddenly flare into visibility. Their distribution is wrong. Their density is wrong. Their response to solar wind is aggressive, erratic, and uneven. This is not how solar system comets behave. These gases are reacting faster, brighter, and farther from the nucleus than models allow. Even worse, the glow refuses to center itself. Instead of forming a neat halo aligned with the sun, the X-ray emission is skewed, twisted, stretched, and offset as if something inside the comet is redirecting the interaction. The shape suggests internal structure, layers, gradients, possibly jets of material venting asymmetrically into space. The geometry looks engineered by physics no one has mapped before. Researchers begin asking questions they did not expect to ask this early. Is the comet shedding material faster than predicted? Is its composition unusually volatile? Or is interstellar matter fundamentally different, shaped by radiation environments far harsher than anything in our solar system? If so, then Earth's models for comet behavior are incomplete. And dangerously so. As XRSIM and XMM Newton data stacks deepen, a disturbing realization sets in. This is not a static event. The glow pulses subtly with changes in solar wind speed. When charged particles intensify, the emission brightens almost instantly. The comet is responding in real time. It is not passive debris drifting through space. It is actively interacting, reacting with the sun in ways scientists have never observed before. And buried inside the noise, early hints emerge of something even more troubling. Lighter gases bleeding outward, far beyond the visible coma, forming a vast invisible cloud that no optical telescope can see. If that cloud grows or destabilizes, everything about the interaction could change. The confirmation has answered one question and opened dozens more. The glow is real. The behavior is unprecedented, and as analysts turn their attention deeper into the data, they realize the next anomaly is already forming. One that could explain why this comet is behaving so violently and what it might do next. The shock deepens the moment the X-ray data is peeled back. What optical telescopes showed felt safe. Water vapor drifting away, carbon compounds behaving exactly as expected, familiar, predictable. But the X-rays tell a different story, and it is not comforting. They cut straight through the illusion and expose what the eye cannot see. Lighter gases are pouring out of the comet's nucleus in proportions that should not exist. Hydrogen dominates the scene, flooding the space around the comet like an invisible tide. Nitrogen appears next, sharp, unmistakable, rising from regions where models predicted nothing at all. This is not background noise. These are signatures with structure, direction, and force. Hydrogen reacts instantly when struck by charged particles from the sun. In the X-ray spectrum, it lights up violently, tracing the invisible collision between solar wind and alien material. Nitrogen follows with its own telltale glow, forming patterns that refuse to stay symmetrical. The emissions do not spread evenly. They stretch, twist, and bend, as if shaped by unseen currents. Scientists watch the maps update in real time, and a quiet realization spreads through the room. The coma is not a calm cloud drifting in space. It is active, it is energized, and it is unstable. The comet is bleeding gas faster than expected, far faster. What appears as a small, faint object through a telescope is hiding something massive. The visible coma is only the core of a much larger structure. X-ray measurements reveal a gas envelope extending hundreds of thousands of miles into space, far beyond the comet's icy nucleus, far beyond its dust tail. This invisible atmosphere dwarfs the object that created it. The comet is not a point. It is a vast, reactive system interacting with the sun on a scale that no one anticipated. Every new data frame raises more questions. Why is hydrogen so dominant? Why does nitrogen appear in such strong concentrations? These elements should exist, but not like this. Not in these ratios, not reacting this intensely. The composition does not cleanly match known comet families from the solar system. It feels foreign, shaped by conditions no longer present here, born around another star, hardened by another radiation field, now forced into a violent encounter with a sun that has never tested material like this before. The chemistry refuses to behave. Solar particles slam into the gas cloud at hundreds of kilometers per second, tearing electrons from atoms and triggering X-ray flashes that ripple outward. The reactions cascade. One collision sparks another. Energy spreads through the cloud like a shock wave. Scientists see regions where gas density spikes suddenly, then collapses as if the comet is shedding layers and pulses. The emission zone grows, contracts, then grows again. This is not passive outgassing. This is interaction under stress, and the scale is wrong. The interaction region is too large for a typical comet, too energetic, too responsive. Either the comet carries an unusually rich supply of light gases, or the material itself reacts differently at an atomic level. Both possibilities are troubling. One suggests the nucleus is far more volatile than expected. The other suggests interstellar matter may behave in ways Earth's models do not yet understand. That realization lands hard. If this is how alien material reacts near a star, then past assumptions about interstellar visitors may be incomplete. Maybe earlier objects passed unnoticed because instruments were not sensitive enough. Maybe their most dangerous behaviors stayed hidden. 3I Atlas is not just revealing itself. It is exposing the limits of current understanding. And it is not slowing down. As the comet races closer, the gas cloud thickens, solar activity fluctuates. Each surge of solar wind causes the X-ray glow to flare again, brighter, wider, more distorted. The chemistry is changing under pressure, and scientists are running out of time to capture it all. Something is building in the data, an escalation that has not yet peaked. Because what comes next is not just chemistry. The next phase reveals how violently the sun can reshape this alien visitor and what happens when solar wind and interstellar gas collide at full force. The impact begins without physical contact, and that is what terrifies the scientists watching the data unfold. The sun never touches 3I Atlas, yet suddenly the comet ignites as if struck. Streams of solar wind, particles moving at millions of miles per hour, slam into the comet's expanding gas cloud. In an instant, electrons are ripped from atoms. Energy spikes. Space itself lights up. X-rays erupt from a region far larger than the comet's visible body, turning the darkness around it into a violent, glowing battlefield. This interaction is not new in theory. Scientists understand charge exchange. They have seen it on ordinary comets before. But never like this. Never on an interstellar object. Never across a zone stretching hundreds of thousands of miles. The brightness surges beyond expectations, then reshapes itself, bending and warping as the solar wind shifts. The glow is not smooth, it fractures into layers. Sharp boundaries appear where none should exist. These are shock fronts, invisible walls where solar particles crash into alien gas and lose control. As the hours pass, gradients emerge. Energy does not fade evenly, it cascades outward, flowing along strange paths that suggest the gas cloud is denser and more reactive than models allow. The comet is not simply being eroded, it is responding. The X-ray emission traces precise contours, outlining the sun's invisible magnetic influence in real time. For the first time, scientists are watching the solar wind draw its own map, using an interstellar body as the canvas. But the scale refuses to make sense. The interaction zone is far too large, too energetic, too persistent. Either 3I Atlas is releasing gas at a rate no one predicted, or the material itself behaves differently under solar assault. The chemistry appears unstable. The reaction zone grows, contracts, then flares again, as if the comet is exposing fresh layers to the oncoming storm. Each surge raises the same question: how much material is really there? In control rooms, silence replaces excitement. This is no longer a visual anomaly. It is a structural concern. If the comet's gas envelope is this vast, what does that say about its interior? Is the nucleus fragile, cracking open under stress? Or is it composed of compounds formed under a star far more violent than our own? The sun's influence should weaken with distance, yet here it looks amplified. And then the data shows something worse. As solar wind conditions fluctuate, the X-ray glow responds almost immediately, faster than expected, as if the comet is primed to react, as if it is tuned to the sun in a way scientists cannot yet explain. The question now is no longer what the sun is doing to 3Y Atlas, but what 3I Atlas might still do as it moves closer, carrying this volatile interaction zone with it. And what the next surge will reveal when the collision intensifies even further. The alarm does not come from a siren, it comes from the data itself. What should have been a clean, predictable signal begins to bend. Scientists watching 3I Atlas realize the comet is not behaving like any object they know. This was supposed to be simple. Observe the pass, measure the gases, confirm expectations, and move on. Instead, the X-ray patterns refuse to line up. The glow does not sit where physics says it should. It twists, stretches, and leans at an angle that does not match solar wind models. The comet is reacting unevenly, as if parts of it are igniting faster than others. Something inside it is responding differently to the sun's pressure, and no existing category explains why. As the analysis deepens, the discomfort grows. The gas mixture leaking from 3I Atlas does not fit neatly into any known comet family. Hydrogen appears in excess. Nitrogen rises where silence was expected. These are not minor differences. They point to a body shaped by another star, another radiation environment, another history entirely. The comet's structure may be unstable, shedding material faster than predicted. Or worse, it may be chemically primed to react violently when exposed to solar wind. Either explanation breaks assumptions. The interaction zone expands again, larger than models allow. The comet is not just losing material, it is transforming under stress. Every new calculation creates another contradiction. Adjust one variable, and 3 others fall apart. The glow's orientation suggests internal asymmetry. The emission strength hints at hidden reserves of volatile gas. Scientists begin to ask the question no one expected to ask so soon. What if interstellar objects are not rare anomalies, but fundamentally different entities that Earth has never learned how to read? 3. I-Atlas stops being a visitor passing through. It becomes a stress test for everything humanity believes about comets, stars, and interstellar matter. And as the comet races closer, the most unsettling realization sets in. This behavior is not stabilizing. It is escalating. The sun's influence is growing stronger by the hour. The reactions are becoming sharper, brighter, and harder to predict. Whatever 3I Atlas truly is, It is not finished revealing itself yet. And the next phase is about to begin. The warning signs do not arrive quietly. As solar wind conditions shift, the X-ray glow around 3I Atlas flickers, fades, then suddenly reignites, brighter, wider, more unstable than before. Instruments watching in real time report sharp spikes, then eerie drop-offs, as if the comet is responding to invisible blows. This is not a steady process. It is volatile. The timing is unforgiving. 3I Atlas is accelerating toward its closest approach to Earth, expected around December 19th, and the window to understand what is happening is collapsing fast. Every hour lost is data that can never be recovered. Across the globe, observatories shift priorities. X-ray telescopes coordinate with infrared scanners, optical trackers, and radio arrays, stacking layers of information as fast as humanly possible. Scientists are no longer just observing a passing object, they are racing a clock. The concern is growing. Interstellar material exposed to sustained solar wind may behave unpredictably as it nears the inner solar system. If the gas cloud expands further, if ionization rates spike again, the X-ray emission could surge without warning. Some models suggest brief but violent outbursts are still possible. Others fail entirely. Too many variables remain unresolved. What unsettles researchers most is what has not appeared yet. Certain atomic signatures are expected at this distance, but they remain absent. Others flicker in and out, appearing for minutes, then vanishing. This suggests rapid chemical changes inside the coma, driven by energy inputs no one fully understands. The comet's invisible envelope may be restructuring itself in real time. If so, the most dramatic phase could still be ahead. The closer it gets, the harder the solar wind strikes, and no one knows what threshold triggers a runaway reaction. As December 19th approaches, tension sharpens. This is likely humanity's only close encounter with this interstellar traveler. There will be no second pass, no correction, no redo. If 3I Atlas releases new elements, fractures internally, or ignites a stronger X-ray flare, it will happen without warning and possibly without explanation. Scientists watch the data streams relentlessly, waiting for the next anomaly to break the silence. Because whatever happens next will not just redefine this comet, it may redefine how alien matter behaves near stars, and the instruments are already detecting something new, something just beginning to rise.